Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to this call today and speaking with me. Just to sort of start off, could you introduce yourself as well as walk us through your journey to get you where you are today?
Yeah, thank you so much for having me. So, my journey, I think, begins when I immigrated to the US. I was born and raised in Peru, and then my family moved to the US, and I started my undergraduate degree in the University of Nevada, Las Vegas. I started as a business major, but and the reason why I was a business major is because my parents were businessmen and they had taught me that that was basically the best way to success. Success being to just keep growing and going up the social ladder, which to them I think is understandable, given their backgrounds of coming from poverty. But for me, I was able to look for more. So in my major, I quickly discovered that actually, much more than business, I like math. And in particular, I was very fond of the whole proofs thing. And I liked going over proofs and trying to construct a logical argument to uh, bigger and better statements. So I majored in mathematics, and I also ended up getting a master's in mathematics. My objective was to become a math professor, to do math research, the same way that my mentors did when I was in that process. But about 2 years ago, maybe now 3 or 4, I started to change my mind. In particular, I wasn't a fan of how, despite how much I worked and despite how impressive my results could be, even if they were top of the field, I still had a very limited impact on society. In particular, the impact was very indirect when I wanted it to be very direct as I can. So pure math wasn't the way for that. And I decided to transition to a field that was all about helping people. And I ended up transitioning to machine learning, mostly because it fit my background really well and because I found it intellectually interesting. And from machine learning, I learned about ways in which I can help in climate change, which is to me a very important subject. So I ended up doing a couple internships in machine learning. Then I did a fellowship in machine learning, and currently I just started a PhD in MIT on electrical engineering and computer science.
Wow, it seems like you've had like a lot of experience in terms of working as well as taking classes. I was just wondering, since you mentioned that you like really enjoyed proofs, I was wondering if there was like a class or activity that you particularly enjoyed and it's like stuck with you.
I think I was very lucky. I think all of my path has been very lucky, from being born in the right family, a family that was very hardworking, to being able to immigrate to the US, to being able to afford higher education. Um, but I think one particular moment that really defined my interest for math was Calculus 1. I didn't have to take it for my business major, but I was curious about it. So I just went ahead and took it. And I was very lucky to have the right professor. My professor was a pure mathematician, pure math professor, and he actually does research in real analysis. I didn't know this back then, but he had a really big emphasis on making calculus as intuitive as possible. He wanted us to understand the statements instead of just memorizing them or memorizing a series of tricks to get to the solution. He wanted us to instead understand why that solution is and how it came to be. And many classes would be all about proving statements. Like, for example, a whole class was on proving the fundamental theorem of calculus. I honestly do not remember the proof, but I remember how I felt. I remember that I felt excited. I remember that I felt like everything made sense. maybe didn't make full sense, but it felt like it felt inspiring that we were able to come up with that argument and that didn't need super advanced mathematics. Us freshmen could do it with the guidance of a professor. So that is what started my interest in proofs, very early and very lucky.
I was also just wondering like what you sort of do with your math background as well as like machine learning background and like what you plan on doing with it.
Yes, so machine learning is a very applicable field, and math is a very uh, sought out background in this field. So machine learning, most people that go into machine learning, or not most people, but a lot of people that go into machine learning actually that's the first thing they see. Like they major in computer science, so they know how to code, they know how to do like compilers and computer architecture and all of that stuff. But that's basically what they know. They know machine learning and the background of machine learning in the direction of computers. Very few actually learn the background of machine learning in mathematics. And turns out machine learning is all about mathematics. Every breakthrough that happens in the field has a mathematical reason. So if you know the mathematics, you know how to steer your research better. And it's even more than that. So um, I think my math background really helped me to develop my machine learning background, my machine learning trajectory, because I had a certificate, I had a degree that verified that I actually know math and that I was good at it. Currently, my math background is more important than ever. I am doing research on how to use machine learning to improve electric grids. So electric grids is electrical engineering, and electricity is all about math. It's really just how to model the real world through math. So the functions are interesting and they take a long time to like understand, but at the end of the day, compared to the math I have seen, they are pretty simple. So based on that, I can build off that. I can apply machine learning in a much more deeper sense, and I can use more advanced math, like for example, graph theory, in my research, which is really exciting and what I hope to do.
Sounds good. I think you mentioned that you've worked in or did research in like using machine learning to sort of better or make like energy or electricity grids more efficient. I was just wondering like I've never like heard of that before, sort of like how did you end up doing that and sort of like where you would see machine learning in a few years or like a decade.
Yeah, so I think my trajectory towards climate change, at first I didn't have the background to really pick a project, so I just started doing anything that was slightly related to climate change. And my starting point was atomic simulations, and the objective of that field is to produce a catalyst that decarbonize industrial processes. So for example, the production of materials can become more efficient and so less carbon intensive if the catalysts used in that production are more efficient. So discovering those new catalysts is a big question and a big challenge in material sciences. So machine learning, through means that I'm not going to delve in right now, can make that process faster. So that was really cool, in particular because one application of this industrial process is the production of hydrogen. Hydrogen can be used to store excess renewable energy so that when renewable energy fluctuates from really high production to low production, hydrogen can kick in as a way to make up for the difference in amounts of production. So that is a really cool application of hydrogen. And my two internships were basically on that subject, even though I didn't know any chemistry, by the way. I still don't know. I know what a catalyst is, but that's as far as I know. Like just the definition. After that, I transitioned to a field of hydrogen storage. And that again was how to make hydrogen viable. And it was machine learning applied for underground hydrogen storage. And it was all of these projects were cool. Hydrogen, how to make industrial processes better. They were really cool. But in my head, I always felt that it wasn't direct enough. The application was interesting, it was promising. If it works out, it has huge potential. But I wanted even more direct research in the problem of climate change. And I started coming to the realization that even if we are able to get extremely optimized electric cars, extremely optimized heaters, extremely well insulated buildings, all of that, even if we get it all right, it does not matter if the source of electricity is not clean. So that's how I came into electric grids, because I saw them as a really big obstacle to decarbonization. Not the only one, but one that has to be solved. So that's why I started doing research in that area. I learned about this subject by talking to a friend of my mentor. My mentor invited one of his friends to our meetings. So I talked to her, and actually she's now my advisor at MIT. So that was a great connection that I made there. And the improvement of the electric grid is a really big point towards decarbonization, because we currently cannot transition to renewable energy fully. Even if we were to install as many solar panels as it is needed, or as many wind turbines as it is needed, or dams as it is needed, or even nuclear energy, maybe nuclear energy is okay for this purpose. But even if we were to install all of this renewable energy, we cannot control when there is wind, when there is sun. So that is a really big obstacle. And electric grids need to be able to handle that. So we need to improve them so that they can handle a larger intake of renewable energy. And that's basically what my research is about.
Sounds good. I was also just curious about, since you talked a lot about like mentoring and your advisors, I was just wondering like how do you sort of go about like developing like mentor-mentee like relationships, and like what's the best way to sort of like get into research?
Well, I'll start by talking about the improving your or having a good connection with your mentor. I think that even getting a mentor can be hard, especially if you're in a school that is not focused on research and maybe it's only focused on classes. My school, I think, is a good example. A lot of the faculty are really focused on teaching, and they can be excellent educators. Like some of the best professors I have met are from my undergrad, but my undergrad is not focused on math research. Like there is only a couple professors that have a really high output of math papers, and I think that was a bit of a obstacle to my developing as a researcher there. But I found that as a beginner, you don't need to be doing top tier research. You don't need to be part of the cutting edge research of any field. You just need to get experience. So I just went to my professors. I just went to office hours, because not because I had a future objective, just because I was curious. I I would see math videos online. There are some channels that I really like Numberphile or Three Blue One Brown, and they would pose really interesting questions, and I would want to solve them before I see the solution. And whenever I couldn't, which it was most of the times, I would go to my professor and ask them, "Hey, there is this problem. How would you approach it, or can you help me solve it?" And it turns out they really like when you do that. Especially the ones that are really focused on giving great lectures, they really like when you want to learn even more. So I think in that sense, I was blessed, because my professors were incredible educators, and they really helped me to grow my skills even more. Uh, and through those connections, I started doing very, very small research projects, like basically toy projects. And I got recommendation letters for research projects in other universities. And I think if I had one advice, especially for a person just beginning undergrad or about to start undergrad, talking to your professors is honestly the best way to get a mentor. Just be curious, go ask questions. Even if you don't have a question in mind, just go ask. So if I were to keep taking courses on this route, what would I eventually learn? Like, what's after calculus 2 or calculus 3, or what's after discrete math, or what is at the very end of the line? Like, what kind of math could I learn? And I think they get excited when students are interested. So if they get excited to help you, then they can become your mentors. And I think that's a really helpful thing to have in your process as a mathematician.
Sounds good. Sort of on the same note, I was wondering if you had any other pieces of advice or like resources, recommendations, honestly, anything for students who are interested in pursuing like a career in math, machine learning, like electrical engineering, honestly, just like any career in the future.
I think that it's easy to get intimidated by the people who are further ahead in their journeys than you. I found it particularly intimidating when I would meet people who had done the International Mathematics Olympiad in high school, or people who um, were attending really prestigious institutions, or people who started doing math, like taking math classes in like college when they were in high school, or in general, honestly, any person who knew more math than I. It was really intimidating to talk to them and see how much more than I they knew. Um, and I think that it's easy to fall into the trap of I am behind, I will never catch up. But you have to fight that feeling. It's not easy to catch up, but you eventually will. It's really important that you just keep trying and that you do it because you like it. If you follow your curiosities, if you stay curious, if you keep asking questions and trying to do as much as you can that you enjoy, you will eventually find subjects that will appreciate your background and will appreciate the experience that you have. It doesn't matter, honestly, what experience you have at this point, especially in the first couple of years of undergrad. It doesn't matter at all what experience you have, as long as you have experience. So getting that experience, even if it's on your own, even if you're reading a book on your own, is really valuable. I think one of the reasons why I got into my first research programs was because I talked about in my application, I talked about how excited I was to be reading books about combinatorics. And I think that shows interest. And honestly, at the early stages, interest is really important and it's not in every applicant. So it can go a long way.
Okay, sounds good. Thank you so much once again for coming to this call and sharing your experience. It was absolutely fantastic. Thank you.
Thank you. Thank you for having me.